Every second, humans consume 19,400 Coca-Cola products worldwide. That's 1.9 billion servings every day, flowing through a global manufacturing network so precisely calibrated that a Coke opened in Tokyo tastes identical to one opened in Toronto or Tunisia. The manufacturing journey we're about to reveal spans 5 continents, involves more than 300 separate quality control checkpoints, and requires 94 different supply chains operating in perfect harmony. What appears to be a simple soft drink is actually one of the most complex global production systems ever created, and today you'll see exactly how it works. Every Coca-Cola you've ever tasted began as raw materials sourced from across the globe, creating one of the most complex supply chain operations in modern manufacturing. The journey from farm to factory involves an intricate web of suppliers, transporters, and quality control specialists spanning 5 continents. This isn't simply about gathering ingredients. It's a precisely orchestrated expedition where timing, quality, and consistency determine whether billions of beverages maintain that signature taste. The process begins with strategic sourcing of key ingredients, each selected from specific regions known for producing the highest quality components. Coca-Cola's procurement teams work with dedicated suppliers who understand the exacting standards required. These relationships often span decades, with some farming families having supplied Coca-Cola for generations, particularly in regions producing specialty botanical ingredients. Water, comprising roughly 85 to 95% of the final product, represents the foundation of every Coca-Cola. The company taps into remarkably diverse water sources depending on the manufacturing location. Alpine facilities might utilize natural spring water flowing from mountain aquifers, while urban bottling plants implement sophisticated filtration systems to process municipal water supplies. Each source requires unique treatment protocols to achieve the company's global water quality standards, with some facilities requiring up to 12 separate filtration and purification steps. The sweetener supply chain diverges into 2 primary streams. North American production relies heavily on high-fructose corn syrup derived from Midwestern cornfields, where specialized processing facilities convert the grain into the precise sweetener specification Coca-Cola requires. International markets generally use cane sugar, sourced primarily from Brazil, India, and Thailand, countries with optimal growing conditions for sugarcane. These sweeteners travel through specialized handling systems to prevent contamination or degradation before reaching manufacturing facilities. Perhaps most fascinating is the procurement of Coca-Cola's flavor components. While the complete formula remains confidential, we know certain ingredients originate from very specific regions. Vanilla extracts come primarily from Madagascar's northeastern growing regions, where farmers harvest and cure the beans using techniques passed down through generations. The controversial coca leaf extract, used in decoconized form, comes exclusively from Peru and Bolivia, where it's processed under strict governmental supervision before being shipped to flavoring facilities. Various citrus oils originate from Mediterranean countries like Spain and Italy, where specific growing conditions produce the exact aromatic profiles needed. Each raw material passes through an average of 34 quality checkpoints before being approved for transport to regional manufacturing centers. These tests evaluate everything from chemical composition to sensory characteristics, ensuring absolute consistency. The transportation itself requires specialized methods: temperature-controlled containers for botanical extracts, sealed tankers for liquid sweeteners, and secure shipping protocols for the more sensitive flavor components. Documentation follows these ingredients at every step, creating an unbroken chain of custody that allows the company to trace any ingredient batch back to its source. This paper trail not only ensures quality, but provides critical protection against potential contamination or tampering. Temperature loggers travel with sensitive materials, recording environmental conditions throughout the journey to verify proper handling. As these ingredients arrive at regional manufacturing hubs, they enter facilities where the famous formula comes together. The actual recipe remains one of the business world's best-kept secrets, locked in an Atlanta vault where reportedly only a select group of executives knows the complete formulation. The security surrounding the formula creates a unique manufacturing challenge. Ingredient specialists know only about their specific components, never seeing the complete recipe or process. The global consistency of Coca-Cola across 6 continents might seem like industrial magic, but behind this uniformity lies a remarkable feat of manufacturing adaptation. While those quality checkpoints ensure perfection within a single facility, the true challenge emerges when scaling these standards across radically different environments worldwide. A Coca-Cola from the highlands of Kenya provides exactly the same taste experience as one produced in bustling Shanghai, despite being manufactured under fundamentally different conditions. Achieving this consistency requires remarkable ingenuity at the local level. The company operates bottling plants in 209 countries, each facing unique challenges that would typically make standardized production nearly impossible. These facilities don't just follow a rigid global template, they're carefully engineered to adapt to local realities while maintaining the brand's non-negotiable quality standards. Water access and quality present perhaps the most significant manufacturing variable. In water-abundant regions like Scandinavia, facilities can focus on simple purification. Meanwhile, in water-stressed areas like Morocco and parts of India, Coca-Cola has pioneered ultra-efficient water recycling systems. The Caldera plant in Rajasthan, India, operates in one of the world's most water-depleted regions, implementing a closed-loop system that recovers and recycles nearly 95% of production water. These facilities often incorporate specialized membrane filtration technologies that weren't even considered necessary in other locations. The sweetener supply chain demonstrates another layer of regional adaptation. Beyond the well-documented difference between corn syrup and cane sugar, numerous other variations exist. European facilities often rely on sugar beet derivatives, which require different dissolution rates and mixing protocols. Some African operations blend multiple sweetener types based on seasonal availability, requiring specialized equipment calibrations that change throughout the year, an adjustment that would be entirely unnecessary in regions with stable sweetener access. The contrast between production facilities in different economic environments is particularly striking. A visit to the Shibuya bottling plant in Tokyo reveals a marvel of automation. Robots navigate the facility floor, transporting pallets, while automated quality inspection systems operate with minimal human intervention. In contrast, facilities in parts of Africa and Southeast Asia maintain higher employment levels, with semi-automated lines that blend mechanical and manual operations. One facility in Vietnam employs over 200 people for the same production capacity that Tokyo achieves with just 40, yet both produce beverages indistinguishable from each other. Regulatory differences further complicate the manufacturing landscape. Safety protocols vary dramatically. Facilities in the European Union operate under strict HACCP, Hazard Analysis Critical Control Point, guidelines that require specific monitoring equipment and documentation procedures. Meanwhile, plants in other regions may follow different but equally rigorous protocols tailored to local requirements. These variations extend to environmental regulations as well, with facilities in California implementing advanced air filtration systems to meet stringent emissions standards that wouldn't be required in most other locations. Even basic climate conditions force significant adaptations. In tropical Thailand, production lines require robust refrigeration systems to maintain proper temperatures during mixing and bottling. The facility in Riyadh, Saudi Arabia, contends with ambient temperatures regularly exceeding 110 degrees Fahrenheit, 43 degrees Celsius, necessitating specialized cooling towers and insulation systems. At the opposite extreme, plants in northern Canada incorporate freeze prevention technologies in their distribution areas to protect products during the loading process in sub-zero conditions. Where secrecy meets precision engineering, Coca-Cola's manufacturing facilities transform those carefully sourced ingredients into the world's most recognizable beverage. These production centers represent industrial automation at its finest. Facilities where computer-controlled systems orchestrate a manufacturing symphony that can produce up to 2,000 perfectly identical cans per minute, with tolerances measured in millimeters. The heart of production begins in the syrup room, a restricted area where the actual magic happens. These sealed chambers operate under strict protocols with limited personnel access. Only specific technicians with clearance can enter. and they follow meticulous procedures dictated by manufacturing guidelines that leave nothing to chance. Inside, precision equipment measures ingredients according to closely timed sequences, with automated systems dispensing components in specific orders and quantities. The syrup-making process requires exact timing between mixing stages to ensure proper integration of the various flavor elements. Temperature control during this phase is absolutely critical. Variations of even 1.5 degrees Celsius can affect how flavors bind together, potentially altering the taste profile that millions of consumers instantly recognize. This is why manufacturing facilities maintain constant environmental monitoring throughout the syrup production process. The mixing vessels themselves are marvels of materials science, constructed from specialized stainless steel alloys that prevent any reaction with the acidic components in the formula. Once the base syrup is prepared, it moves to the blending stage where it meets purified water. Unlike typical food manufacturing that might tolerate minor variations, Coca-Cola's blending systems operate with pharmaceutical-grade precision. Computer-controlled flow meters measure the exact ratio of syrup to water, adjusting in real time based on continuous density readings. Most consumers don't realize that this precision extends beyond mere consistency. It's actually calibrated differently at facilities based on their geographic location. The carbonation process represents another engineering challenge that varies by facility. Plants located at higher elevations like Mexico City or Denver require different pressure settings than those at sea level. At higher altitudes, carbonation systems must compensate for the lower atmospheric pressure, which would otherwise result in excessive fizzing and inconsistent carbonation. The specialized equipment uses temperature-controlled chambers where carbon dioxide is dissolved into the mixture under carefully regulated pressure, creating the signature effervescence that consumers expect. The filling operation itself is a high-speed marvel of modern manufacturing. Rotary filling machines can process up to 2,000 containers per minute. That's 33 beverages every second, with each container receiving exactly the same volume. These machines represent the pinnacle of precision engineering, with filling nozzles that can detect and adjust for microscopic variations in container shapes. Optical inspection systems scan each container before filling, checking for defects as small as 0.3 millimeters, smaller than a grain of salt, and automatically rejecting any that don't meet standards. Throughout the entire manufacturing process, quality control happens at over 70 different checkpoints. These include automated systems that analyze sugar content, carbonation levels, and pH values, coupled with sensory evaluations where trained personnel perform systematic tastings. The facilities also employ spectrographic analysis to ensure color consistency and gas chromatography to verify flavor profiles match exact specifications. Even the torque applied to bottle caps is measured to ensure proper sealing that maintains carbonation levels during distribution. As our journey through Coca-Cola's manufacturing universe concludes, what stands out isn't merely the staggering volume of production, those 19,400 beverages consumed every second around the world, but the remarkable engineering achievement it represents. Consider the precision required, a global network that transforms diverse regional ingredients into products so consistent that consumers cannot detect differences between bottles produced on opposite sides of the planet. This manufacturing ecosystem represents one of humanity's most impressive logistical achievements. Operating continuously without pause, the approximately 2 billion daily servings flow through a production network that never sleeps, creating a perpetual river of identical products despite dramatically different operating environments. From Arctic facilities battling freezing temperatures to desert plants managing extreme heat, each production line maintains tolerances measured in fractions of millimeters. While processing thousands of containers per minute, what we're witnessing is manufacturing at its most refined. A global system that proves consistency and adaptability can coexist at massive scale. Every Coca-Cola bottle represents a quiet triumph of industrial standardization, a testament to what becomes possible when engineering precision meets global logistics.